Hello again. All right, lesson 2-3, more about line of best fit stuff. All right, our line of best fit, or the regression line, will always contain the point x bar, y bar. Now, hopefully you remember from chapter 1 that x bar was the mean or the average of the x values. So hopefully it's obvious that y bar is going to be the mean or the average of the y values. So what this first sentence is saying here is if you take all the x values, find the average. Take all the y values, find the average. That point, the average of the x's, the average of the y's, will always be on your line of best fit. So just to make sure that I'm not lying to you all, we're going to verify that that point really is on the regression line for the data we looked at last time, which was the carat weight of the diamonds versus the price. So hopefully you still have that data in your calculator. If you don't have that data in your calculator, pull out your notes from Monday and have Mr. Cox pause the video so that you can get that data back in your calculator. All right, so now we're going to assume that everybody has the data back in their calculator. Okay, and the regression line that we found last class for that data was price equals 5,502 times weight minus 372.7. All right, so we need to find the x bar and y bar numbers for that data. So we're going to go to a calculator page, and we're going to tell our calculator to find the mean of the price and the mean of the weight. Or, if you would rather, you can do one variable statistics on both of those lists, and you can get your means that way, but I think typing in the word mean is actually easier. All right, so using those two numbers, we now know that the point x bar, y bar, that our x bar is 0.212 and our y bar is 793.7. Okay, so we want to verify that that point is actually on the line. So if it is on the line, then 5,502 times 0.212 minus 372.7 would equal this 793.7 number. So on your calculator, you're going to do the 5502 times 0.212 minus 372.7, and you get the 793.7 number. So that point works, which means that that point is in fact on the line of best fit. All right, next thing we're going to talk about is correlation. The symbol for correlation is the letter R right here. Okay, you need to know that. You need to know if I ask you for correlation, it's R, and the reason you need to know that is because that's how your calculator is going to label it. What correlation does is it measures the strength and the direction, both things, of the linear relationship between two variables. Strength being how linear is the data, and direction as in is it uphill, positive, or downhill, negative, just like slope of a line that you did back in Algebra 1. Your R numbers will always fall in the range from -1 to +1. Now, people sometimes get the mistaken impression that -1 is bad. That is not the case, okay? -1 just means that the data is perfectly linear going downhill. So this one right here has an R value of -1, perfectly linear downhill. Okay, if the data is perfectly linear uphill, it will have an R value of +1, like that one. Okay, most data is not perfectly linear. Doesn't fall either perfectly uphill or downhill, especially real data. Okay, usually when you graph real data, it ends up kind of blobby, like this one and like this one. Okay, not perfectly linear, but you can still see that there's an uphill and a downhill trend. The bottom one there in the middle is definitely tighter than the top one. Therefore, that R number is closer to -1. Okay, if the data is just a random blob with no pattern at all, like that C one right there, then it's going to have an R value of 0. Okay, picture F also has an R value of 0 because it's not linear. When the data is making a parabola like this, okay, remember that R only measures the strength of the linear relationship, so if it makes a parabola, it is not going to have a good R value. So, once again, R falls somewhere in the range from -1 to +1, -1 perfectly linear downhill, +1 is going to be perfectly linear uphill, 0 is just a random scatter with no relationship. A 0.5 is going to be uphill, but it's going to be blobby. That's the technical math word, is blobby. A -0.5 is going to be downhill and blobby. All right, so if we want to find the correlation between how much does the diamond weigh and the price, you are going to go to your calculator page, and it's actually on the same page where we went to get the regression line, the line of best fit. You're going to hit Menu, Statistics, Stat Calculations, Linear Regression, which is number 3. Our X list, again, is the weight. The Y list is the price. And you're going to hit OK. And on that screen right there, we have an R number of 0.9912. Now, if you remember what the scatter plot looked like from Monday, hopefully that R number makes sense because that data was pretty linear. If you go back and look at your notes from before, it did a pretty good job of lining up along that regression line that we found. Okay, so this right here is your R number of 0.9912. All right, word of caution about correlation. Okay, correlation does not tell you that one thing causes the other. It only means that there's an association between the two variables and how linear it is. For example, let's say we wanted to graph number of people that drowned every month of the year and how much ice cream was consumed. That data actually has a pretty strong positive correlation. More ice cream, more people drowned. Now, hopefully, obviously, you wouldn't say that ice cream causes people to drown. There's a lurking variable there. Temperature. When it's hotter outside, more people eat ice cream. When it's hotter outside, more people go swimming and therefore more people drown. But you can't say one thing causes the other. So, again, just because two things are correlated does not mean that one thing causes the other. All right, that's it for today. You got your homework assignment. Have fun, and see you guys on Friday.